Okay, let's discuss another topic in regarding functions, and this is called piecewise defined functions. So here we have a so-called piecewise defined function. So what does it say? It says this is what f of x is. So what is f of x? We use these big brackets, and what we do is we say, okay, whenever x is less, you mention a range here. So anyway, whenever x is less than 1, use this formula to find out what the height is. Whenever x is greater than or equal to 1, use this formula to find out what the height is. So what does that mean? So whenever x is less than 1, so let's put 1 here. Here's 1. Okay, so whenever x is less than 1, so everything from here on over, use this formula. So we know what this graph of this formula looks like. So we know it looks something like this. It's a parabola. And I use the dotted line here to indicate that we're not using that when x is greater than 1. We're not using this formula. So I don't want to have the line there. But here, this is just a parabola. So if I want to know, for example, when I put in -2, for example, like that, then of course I know that the height, because I'm using this formula, that I know that the height when I put in -2 should be 4. So in other words, it's -2, 4 is the coordinates of this point. Sorry. Well, let me undo that. You know that it continues. I can't draw it very well, but continues. So -2, 4. And so when x is -2, it's 4. That is, we're using this formula. However, we don't use that formula over here. For example, when x is 2, we don't use that formula, because this says only use this formula when x is less than 1. So what do we use over here when x is equal to 2? We don't use this because it's not less than 1. So this one applies in that case. So when x is greater than or equal to 1, use this formula. So I'm supposed to use this. So if I put in 2 into this, what do I get? I get 4. So where's 4? I already put 4 up here, so I guess this is 4. So I'm talking about like something up here. Now it looks like it's right on that parabola. In fact, it is. But that was just a coincidence that I chose 2. Let's put in 3. So what would I get for 3? So here I would get, I'm using this formula because x is 3, which is greater than 1, so use this formula. So I get 5. So where's 5? I don't know where 5 is, but maybe it's here. Something like that. Okay. So yeah. So actually, if I wanted to graph this is actually y equals x plus 2, and we know how to graph that. So if this is 4, this was about 2. So this is the line y equals x plus 2. Looks something like that. But I don't want to use, I'm only using it to the right of 1. So all of this to the left should be a dashed line. So let me try and do that. So it might look something like that. That's not a very good picture, but you get the idea that this formula here only applies to the right of 2, to the right of 1, or actually right at 1, because this is greater than or equal to 1. So this one starts at 1, and this one goes up to 1. So actually the way we would do this is we put a solid circle there, and we put an open circle there. And that would be to indicate that this one has, this formula here has the greater than or equal to sign, and this formula here has only the less than sign, not less than or equal to. So we put a circle here, and it would look like that. So all of this is called a piecewise defined function. So actually we're not limited to just having 2 pieces. We could have as many pieces as we want. Like here we have 3 pieces. So this says when x is less than 1, do one thing, use one formula. When x is between -1 and 2, do something else. Use this formula. When x is greater than 2, do something else. Do this formula. Of course, we could change it. We could have as many pieces as we want. And that would give you some kind of graph where when I'm not going to try and draw this properly, but when x is less than -1, use some formula. So 2x plus 1 looks like 2x, so here's 1, slope of 2. So it's probably like here, maybe. I don't know what it looks like really, but that's it. It looks like that. And then, it would be like dots up here. We wouldn't use that part. And then when x is between -1 and 2, so up to 2, maybe 2 is over here, use a parabola formula. So whatever that looks like, -1, I guess, would be 1. And this would go like that and go up to like there, something like this. And then, and these would, by the way, since these are less than or equal to, these would be filled in like that, and this would be filled in like that, and this would be open like that. And I don't know if I drew this correctly or not, but I'm just... And then when x is greater than 2, use x plus 5. So I don't know what that looks like, but maybe this was 4, so this is x plus 2, 7. So it might be like this, something like that. So this would be the picture now. So this would be a piecewise defined function with 3 pieces. And you could have as many pieces as you want or as you need.